Okay, hi guys. Today we are doing graphing exponential functions. So in this lesson, we're going to be looking at what the difference in the graphs of growth and decay are and how their domain and range are and what the transformations look like for exponential functions. So for our parent function, we have y for growth. We have y equals a times b to the power of x. So remember, because we are dealing with exponential, our variable is in the exponent. And for growth, we have b has to be greater than 1 because it's going to be growing. Our type of graph is going to be continuous and increasing. Okay. And then, so we're going to graph these. For our parent function, our asymptote is going to be 0. So our asymptote is 0. And we are going to be intercepting at 0, 1. So our graph essentially is going to be growing, increasing to the right. Okay. So our domain, we see it goes as far left as it can, as far right as it can. So we know our domain must be all real numbers. And then we have our range. Our graph cannot go below or touch 0, so we know y has to be greater than 0. Our asymptote, we said, is our number out here on the outside, so we have 0. So remember, it's going to be y equals 0 is our horizontal asymptote, and our intercept is 0, 1. Okay. For our decay, same parent function, a times b to the power of x, but b has to be greater than 0 and less than 1. Okay, that means it is going to be a fraction. It is not negative, it is still positive, but it is between 0 and 1. And our type of graph, again, is continuous. And instead of increasing for decay, we are decreasing. Okay. And our domain, again, we are dealing with a asymptote of 0. So we have y equals 0, and our intercept is going to be 1. But instead of growing to the right, we're going to be decaying and decreasing to the right. Okay, so our domain, it goes as far left as it goes right. So we have, again, all real numbers. And we cannot go below 0. So again, our range has to be y is greater than 0. Our intercept, again, is 0, 1. That is for exponential growth and decay. Okay, our transformations. Whenever we're looking at our transformations, we have A. A is the orientation or the shape. Remember, if it is negative, it does reflect over the x-axis. And if this also determines if it is a vertical or a horizontal stretch. This is like your steepness of the graph. And then our horizontal translation, h, if there's nothing else in the exponent, then the h is just 0. So if x is by itself, h is 0. And remember, this goes our shift. It shifts the graph left or right and is always opposite. Okay, and then our k shifts the graph up and down. Okay, our k is also our asymptote. So you need to make sure you do know that your k is also your asymptote. Okay. Oops. So for the next page, we're going to be looking at just the examples here. And we are going to be just working out some of these problems to see what their graphs would look like. So our first one is y equals 2 to the power of x. And it is plus 1. Okay, So we're looking at if our A is growth or decay. So our A in this case is just 2 as far as we know. And our H, we don't have anything up here in this exponent, so we know it is 0. And then our K is just 1. So we know 2 is greater than 1. So we know this must have to be growth. And let's go ahead and use the variables -1, 0, 1, 2, 3 for our x variables or x values. So I'm going to plug in 2 to the power of -1. I'm just replacing my x value in place of x to solve for y. 2 to the power of -1 is 0.5 plus 1 is 1.5. 2 to the power of 0, anything to the 0 power is 1. 1 plus 1 is 2. 2 to the power of 1 is 2, plus 1 is 3. 2 squared is 4, plus 1 is 5. 2 cubed is 8, plus 1 is 9. Now I can go ahead and graph these. I have -1, 1.5 here. And then I have 0, 2. Oh, whoops, sorry, -1, 1.5 here. Sorry, that was my bad. And then I have 1, 3, 2, 5, and 3, 9. Okay, and our asymptote is 1. So we know our graph cannot go below our asymptote. And so therefore, our graph should look like this. Okay, moving on to the next one. We have 0.25 times 4 to the power of x minus 6. Okay, our b is 4, so we know this has to be growth, is greater than 1. And then our a is 0.25. Our h, there's nothing up here in my exponent, so it's 0. And our k is -6. Remember, this is also our asymptote. Okay, so I'm going to go ahead and use the same values, -1, 0, 1, 2, 3. 0.25 times 4 to the power of -1 minus 6 equals -5.9. If you plug that into your calculator, 0.25 times 4 to the power of 0 minus 6 equals -5.75. 0.25 times 4 to the power of 1 minus 6 equals -5. 0.25 times 4 squared minus 6 equals -2. And 0.25 times 4, not squared, cubed, minus 6 equals 10. So now we're going to go ahead and graph these. Oh, we forgot our domain and range. We'll go back in just a second and finish that one. So here I have -1 and -5.9. So we're going to go -1, 3, 4, 5.9, almost touching. And remember, my asymptote is -6. So I cannot cross that line. 0 and -5.75, so probably right about there. 1 and -5, 2 and -2, 3 and +10. So we know it's going to go way up here somewhere. So our graph is going to be increasing from left to right and does not go below -6. Okay, so our domain is all real numbers. It goes as far left as it goes right. And our range has to be y needs to be greater than -6. Let's go back and do that domain and range for this top one. Domain is all real numbers. And it cannot go any lower than +1 because that is my asymptote. So y has to be greater than 1. Okay, and then we're going to go ahead and do our last example. I think I had you guys try this one out on your own. So we changed this to 0.4 instead of dealing with this fraction all the time. And so we know this is less, our b is less than 1, so we are going to be dealing with decay this time. Our a is -3. Our h for this time, we do have 4, and remember it is positive 4, not negative, because if it is attached to this x, it is always opposite. And our k, our asymptote, is 2. So this one I used a little different values just so we can actually get it on our graph, because if it's not on your graph, it's going to be pretty hard to graph these numbers. They're very small numbers. So for 2, I had -3 times 0.4, and then I had -2 power, because 2 minus 4 is -2, plus 2, I got -16.75. Okay, -3 times 0.4, and then I had to the -1 power, plus 2, because if it's 3 minus 4 is -1, equals -5.5. -3 times 0.4. 4 minus 4 is 0, and plus 2, because I have this -4 in case you're wondering why I'm subtracting 4. 4 minus 4 would give me to the power of 0. That gives me -1. -3 times 0.4. 5 minus 4 is 1, so to the first power, plus 2 equals 0.8. And -3 times 0.4. 6 minus 4 is 2, so squared plus 2 equals 1.52. Let's go ahead and graph these. So I have 2 and -16.5. It's going to 0.75. It's going to be way down below my graph. 3 and -5.5. 2, 3, 4, 5.5 is here. 4 and -1. 5 and 0.8. 6 and 1.5. Our asymptote is +2. So our graph cannot cross this line up here. We know that's going way down below, and it's going to go something like this. Okay, so that would be what our graph looks like. Our domain goes as far left as it goes right, so it would be all real numbers. And our range is going to be y. And in this case, it's going to be less because we are going down. So this is going to be less than. So y has to be less than 2. Okay. All right, guys, if you have questions, please send me a remind. Make sure you get your assignment done, and we'll see y'all later.